Chapter 14, Sample Problem Number 13. The drawings represent snapshots taken of waves traveling to the right along strings. The grids shown in the background are identical. The waves all have the same speed, but their amplitudes vary. So this will be important, maybe. And we are asked to rank the wavelengths of the waves. So lambda is defined as the distance for one repetition of the wave to an identical point. So if we go over to here, we can start maybe marking some points. For case A, we might say rising 0 to the next rising 0. That seems to be 3. But here, rising 0 to the next rising 0 is only 2. Here, rising 0 goes to what would be the rising 0 over here, and that looks to be 6. And then here we have the rising 0 to the next rising 0, and that would be 6. If you're uncomfortable about using the edge of the graph, we could take peak to trough distance and then multiply by 2. And we'd see that to be the same here. And that would give us, that's half the wavelength, so the wavelength would be 6. Notice that the amplitude doesn't matter in this, so it doesn't matter that D is larger than C in amplitude. And then it's pretty easy now just to read that the longest wavelengths are C or D, and the next one is A, and the next one is B.